enter their name into the chat. And then if you would enter any questions in the chat, that would be very grateful. And my supervisor, who is here, who will, help me greatly with questions or things that maybe I will overlook inadvertently, like raised hands, will help keep me focused. And so I'd like to welcome Gary Jones with United, well, I don't know why I confused that, Printing United Alliance. And as he had expressed, Graphic Arts Technical Foundation was one group he was part of. He was part of Printing Industries of America. I think that was the name. He was affiliated with a number of the Graphic Arts National Environmental Health and Safety Conferences. I remember meeting him in '97. I met him several times in Indianapolis. They helped to facilitate a environmental compliance manual for the graphic arts industry. He's helped out with a RAC rule in the northwest part of the state. He has helped me prepare for presentations. He's a wealth of knowledge. And so I welcome you, Gary Jones, and take it away.
Oh, well, thank you, Mark. Good afternoon, everyone. Thank you for taking the time out of your busy schedule to sit in on today's program. And as Mark indicated, he and I have known each other for quite some time. And if you look at our images, you'll see that we have a lot of snow on our roof. So we've been around for quite some time. And this is pretty exciting for me. I've had a rich history with working with the Small Business Assistance Program folks through the years. I'm now in my 38th year of working in the environmental health and safety field with printing, exclusively with printing, believe it or not. So Mark had reached out to me and asked me to put together a presentation to update, really update a presentation to really provide you with some insight as to what's happening in the world of printing. And that's a pretty broad term. We're going to talk a little bit about that, but primarily focusing on what I call the digital revolution, so to speak, although it seems like it's something that happened overnight, but it's been many, many years in the making. And really what's happening from the printing industry's perspective is that the digital printing technologies, and this is what we're going to talk about today's program, is really becoming, I would say, predominant in terms of popularity. Not necessarily volume of run length yet, but as the digital technologies continue to improve, research and development goes into digital technologies, it's taking more and more of the what we call conventional or analog printing volume and switching over to digital. And there's many advantages to that, which we'll talk about. So since I'm not sure if everyone's familiar with what printing is, I thought it would make sense for us to take a little bit of time just to talk about what is printing. And what's interesting is that the best way I could describe printing, or the best statement I want to use, is that printing is the largest industry that you've never heard of, but you interact with it on a daily basis. And I would hazard to say that in reality, there's nothing that you do through the course of a day where you don't interact with print in some way, shape, or form. So from a broad perspective, print is basically the application of text and images for mass communication. Quite frankly, that's the heart and soul of printing. Print has advantages, and of course we know there's digital communication, which is really the advent of the internet, which is around for quite some time, but it still remains inexpensive to mass produce, inexpensive generally to distribute. It's durable, stylish. There's many things that you can do with print. And on this slide, there's several images of print, of which you would commonly encounter. I mean, typically when you think of print, you may think immediately maybe I'm working with a book, or maybe I like to read a certain magazine. I have a subscription to a monthly magazine that I like to read, and that's printed. But you don't realize it is that you say, for example, when you get up in the morning and you're going to have breakfast. You go over to your refrigerator, you open up the refrigerator, you pull out, say, a carton of orange juice. Well, that carton has been printed and converted. Perhaps you grab tomato juice and there's a glass container and there's a label on it. Well, that label has been printed and converted. You go over to your microwave and say you're going to warm up your Danish. You may pull it out of a box that's been printed, your favorite bakery store, or you go to the grocery store, put it in the microwave, and you start up the microwave, and believe it or not, the keypad on your microwave is printed, and that's called industrial printing. And so there's conductive circuits that get printed. And so, as I said, printing really, there's not much you do throughout the course of your day. Say you put on a shirt and say it's your favorite football team, because we're moving into football season. For Mark, probably the Indianapolis Colts. And so maybe you put on an Indianapolis Colts shirt. Well, that's been printed. That's apparel decoration. So reality in terms of printing, another thing that gets printed is the dashboard on your automobile. The dashboard on your automobile is actually screen printed and thermoformed. You might be driving down a highway and you see a delivery van or a vehicle that has some type of advertising on it, or identification for a business. That's called a business. That's called a vehicle wrap. You look at a billboard, for example, that's printed and put up there. Now there's electronic billboards, but most of them are still printed. As I said, printing, as I said, is the largest industry that you've never heard of, but you interact with it on a daily basis. And to me, it's just an absolutely fascinating industry to be involved in. I've been involved in it for 38 years. I'm learning every day. I continue to learn, and the way our industry is evolving is that we're excited in terms of where it's moving with technology. So, with that little bit of introduction, let's talk about digital. What do we mean by digital? Compared to what? Digital compared to what? So, from the printing industry's perspective, it's really digital versus analog, what we call analog or traditional type of printing. So on the left is an image of a digital output device or a digital press. On the right are several examples of different types of printing that we would view as analog. So if we start in the top left-hand corner, that's an image of screen printing. And basically, if maybe you may have been exposed to screen printing when you were in high school, where you made some type of print on a screen, and essentially the ink is pushed through the image on a screen to adhere the ink to a substrate. Typically, it could be paper. More times than not, it's some type of clothing or apparel. On the right-hand side, upper right-hand side, is a lithographic printing plate. Lithographic printing has been around for quite some time. It was invented way back in the Middle Ages, and actually printing on stone was how lithographic printing first came about. And what happens with lithographic printing is that the image is transferred from the plate to an intermediate surface called a blanket, which then transferred to the substrate. The lower left-hand corner is an example of flexographic printing. Now, flexographic printing, similar to letterpress printing, is a raised image. And so the inked image is transferred from that raised image to the substrate directly. And in the lower right-hand corner is something called a gravure cylinder. It's actually an engraved cylinder where the image area is recessed relative to the non-image area, and that there are minute wells that are in the cylinder, and that they get filled up with ink, and then the ink is transferred to the substrate. And a great example, for flexographic printing would be potato chip bags are typically printed with flexographic printing. When you look at rotogravure printing, don't want to think typically of very long runs of printing. So, for example, Chiquita banana stickers that you would see in the grocery store, those are going to be done by gravure, because think of the millions of stickers that get printed that have, say, Chiquita bananas on it. Or another example for gravure printing that isn't text and images, but a lot of laminates. So, for example, if you have a piece of furniture that has a wood grain laminate, a lot of times that laminate is actually printed. And in some cases, if it's a flexible laminate, it's done for gravure. And if it's a non-flexible, it's printed by flexo. And so each of these print processes produce different types of products. The products that are driven are typically the type of product, usually substrate driven. So the type of substrate will drive typically the process that's used from an analog basis. But as we said, the really focus isn't on analog printing, it's on digital printing. And what's exciting about digital printing is that with the advances in digital printing, there isn't one part of our traditional analog world that hasn't been impacted by digital printing. In other words, there's digital printing is used to print to print laminates on hard surfaces. Digital printing is used to print on paper substrates. Digital printing is used to print on plastic substrates. So digital printing has made some tremendous inroads into the printing industry, and it has a lot of very distinct advantages in terms of printing digital versus analog printing. So where we want to start our journey is basically a term that's called pre-press. So as the name implies, pre-press are all the activities that occur up to the point of the press room, or where the presses are, where the ink is actually hitting the substrate. So in the pre-press area, digital kind of hit first, where in the old analog approach, and the next slide, this may make a little bit more sense to you. But in the old analog approach, we used a lot of film. Black and white film chemistry was used as an intermediate to carry images from, say, the origination to the what we call image carrier, or the plate. I put that in air quotes, the plate. So we first started with computer generated film, which was a huge advantage in terms of technology, a leap forward. And now we're actually doing direct to plate technology. We're actually doing direct to screen technology. So we're actually eliminated film. In fact, I would say you would be very hard pressed if you walked into any printer today and saw them still using film in some way, shape, or form. Film has really been supplemented and replaced by direct to types of technologies. We're actually taking the image and imaging it directly onto the image carrier. So if it's a plate or a screen, for example, if it's a gravure cylinder, it's actually being engraved now via computers instead of putting film negatives on and imaging those. So the advantages from a pollution prevention perspective is that, first of all, we've eliminated a whole step of process. We have no film, no photo processing chemicals. When I first started in the industry, this was the typically way that plates were imaged. Digital was just kind of a twinkle in our eye to some extent. But basically, the evolution and revolution that has occurred has just been phenomenal, because we've eliminated black and white. Basically, it's black and white film chemistry. There's no developer. There's no fixer. There's no silver. Silver used to be a problem. And regardless of how good that you had a silver recovery system in your operation, there was still a little bit of silver that was discharged to the sewer authority. And so we always had to worry about the discharge limits for silver coming out of our pre-press areas. And what's interesting is, as the evolution has evolved, the plate imaging and screen imaging chemistry has become a lot less harsh. It's more water-based, although it doesn't mean to say that you can't run into some issues, especially like in litho printing. The plate chemistry can sometimes have a very high pH, but we're seeing over time, we're seeing that pH come down. And so that pH may be an issue where it requires some neutralization prior to discharge. And then some litho plates don't even need to be developed. You can image them, and actually the non-image area washes off on the analog press through the fountain solution. And so there's even continued changes with respect to our digital pre-press area. And there's advantages, obviously, both for business and the environment. We have reduced pollution. We have reduced handling, I guess, of images. You have better images because you no longer have an intermediate, so you don't have a reduction in quality of your images. And so you don't need as much material. You don't need as much manpower or people to be in your pre-press area in order to generate those direct to types of situations. But also keep in mind too, as we look at this flow, and maybe this better describes where we've moved as an industry. In fact, in the old analog process, I won't go through every one of these steps, but just to give you an appreciation, you would have the design phase first, and they would have designers that were designing the piece. Then you would have a typesetting. If that term sounds familiar, you'd have typesetting. And then you would have to go to camera. And what do you mean by camera? Well, what's interesting about printing is that printing cannot, even when you may open up a magazine and you might be looking at, for example, a photograph or an image of an automobile or of a nice piece of furniture. And you look at that and you say, wow, that looks like a great photograph. What's interesting about printing is that printing cannot reproduce a photograph. Printing is not a continuous, cannot reproduce a continuous tone image. So what that means is that we have to break that image down into at least 4 primary colors of black, cyan, magenta, and yellow. And with those 4 colors, we're able to reproduce almost every image that's in the spectra. There's other inks that are out there called spot inks, or specialty colors, but basically you have to break an image down. So in the camera room, literally these printing facilities had these, think of an old bellows camera that was on steroids that took up the size of a room. You'd have to take a picture of the picture with filters on the camera lens to pull out the blue, to pull out the red, to pull out the yellow, to pull out the black part of it. And then you would have to do stripping. You'd have to take each of those images with the text and strip them into what they called a flat. Then you would take that and you would image it onto film. And then that would then be imaged onto a plate, which was then put on the press, and then it would be printed and then it would be finished. That was the old analog. So now if you jump down to the bottom, basically you have creation that occurs on a computer. You may have some scanning involved, but a lot of times now with photographs being digital, you don't even need to do scanning. And then you go right from the computer, you lay out the job and you go right to the output device, digital printing, and then to finishing. So if you think about removing all those steps out of that workflow, it's amazing what digital has done. And then from the analog press to the digital press, you don't even have to make plates. So in other words, we're not even generating plates or other image carriers depending upon the process that you're dealing with. And so therefore you think about the waste reduction, the pollution reduction, the increase in workflow, the increase in efficiency that you have at printing operations. It's just been a phenomenal revolution. You can see why, in a lot of instances, why digital has taken over. Probably the biggest limiting force for digital is going to be run length and cost. And so there, I've seen over the years, we've seen a lot of analysis, based on the run length, the cost per page or cost per impression or cost per material produced comes down as digital gets better, it gets more efficient, and it becomes a better quality, higher quality output. You're able to produce more product at a lower cost using digital printing. And so when you have that economic argument, obviously digital printing is going to win. So with that being said, let's talk about the different types of digital printing that you encounter. And I wanted to lead off this section of the presentation with really a review of what we call electrophotographic printing. Boy, that's a fancy term. Basically, the common term that everybody uses is called Xerox. Now, we know that Xerox machines have been around for quite some time. Decades Xerox has been around. In fact, people still refer to making a photocopy of something a Xerox. I'm going to go Xerox this, even though you may not even have a Xerox machine in your facility. But what is interesting is that historically, when you had a photocopy machine, you were limited to basically black and white. Those were relatively small types of photocopiers. You didn't have the capability to run a lot of impressions or a lot of sheets through those. And so one of the first major changes to digital printing is basically they took and improved the Xerox process. And now, and just to give you an idea of how the process works, if you're not familiar with Xerox or electrophotographic printing, basically, see, I use the term, basically you have you have a drum that receives an electrostatic image. In other words, the drum is a photoreceptor and it gets charged via a laser to accept the toner, which is an opposite charge. The toner is a very, very finely powdered ink. It sticks to the charged area. It's then transferred to the substrate, typically paper, and then fused using heat and pressure. And then what's happened with this technology is if you can see the images on the right, those don't look like your typical photocopier that you might see in your office. So essentially what's happened is that you now are able to get what we call four color printing. Remember, I was talking about the inability to produce a continuous tone image or a photograph. So the term that's used in printing is four color process printing. So when you have the four colors, you have the black, cyan, magenta, and yellow. You have the four colors we refer to as four color process printing. So basically, now I can take using electrophotographic printing with these really highly advanced, sophisticated machines, I can actually do four color process printing. I can do relatively great quality images basically using the dry toner system. In addition, some of the dry toners, you can actually get finishes on them that are raised images that have a tactile finish. It's really cool. You can actually add a little bit of gloss coating on it. And so if you notice, there's also the ability on some of these machines to actually, instead of producing individual pages and taking it and then binding those pages together like you have in a traditional workflow, you actually have some inline finishing that you're capable of doing. You can actually do tape bound, and you can actually produce a book off of these types of machines. So you can do four color work. You can actually do books and booklets coming right off these types of machines. In fact, a lot of times, like for example, uh, if you order books on Amazon, understand in the traditional, the old non-digital world, in order for you to order a single book, say off Amazon, or you go to your favorite bookstore and they don't have a book in stock and you have to order it. What happens now is that there's actually companies that have all that text, all that image, the whole layout sitting in a digital file. And whenever you want to order a book to read, you can actually use these types of printing presses, these types of machines to print a copy of one. That's what digital printing is, allows you to print a version of one versus having to print hundreds or thousands of copies of book, put them in a warehouse and hope that somebody buys them. Now they can produce this printing on demand. And so when you order a book, it goes, and within 24 hours, that order is received, it's printed, it's bound, it's finished, and that book is being shipped back to you at your house. And that's what digital printing has allowed the industry to do, is to become a lot more responsive to customer demands. And typically that's going to be this type of printing device. Another huge breakthrough that happened, and I put I put these slides in order. It's called electro ink, and the only company doing it is HP, but it's also referred to as HP Indigo as another name for the technology. And what's interesting about the Indigo press basically is that it's similar to the dry toner. It's similar to the electrophotographic. It's electrostatic image, basically on a photoreceptor drum. But in this case, instead of it being a dry toner, it's actually a liquid ink. The ink is actually diluted with something called imaging oil. So it's a liquid ink that sticks to the drum. It's then transferred to a blanket, as in lithographic printing, and then transferred from the blanket to the substrate. So I like to think of this as a hybrid. I almost like to think of this as a digital offset press, because the thing that's been eliminated is the lithographic printing plate, but what's in its place is a drum similar to the electrophotographic or quite frankly a Xerox drum. So you have that scenario where the image is created on the drum from the computer. Basically, there's no plate, no intermediary. And then the same scenario happens here, is that you could produce a single product if you wanted to. And so these indigo presses over the years have become a lot more sophisticated. Similar to the electrophotographic, there's some inline finishing that can be done. In a lot of instances, though, they're just printing the sheets, and then in the individual sheets, product will go off to be finished. But the indigo is now making, in addition to printing on paper, indigo can now print on plastic substrates. They can do packaging, a lot of short-run packaging, and so you see a lot of a great example would be a lot of microbreweries that you see that pop up from time to time. And I know here in Western Pennsylvania, where I'm from, they're pretty popular. And so you have folks that are going to do limited production, and so they're not gonna pay the cost of having to go through the old analog process. They can go to a printer that's printing things on a digital basis, and they can get wraps to put on their cans. The shrink wraps can go on those that can be printed in limited quantity. They're going to be coming off a digital press, and so it is fascinating in terms of where Indigo is moving with respect to its applications. It originally started in commercial printing, but now it's being used for labels, it's being used for photo books, it's being used for packaging, and it continues to grow in terms of its quality and run length. And that's the key thing, is getting the run lengths up. Now, a relatively new addition to the digital print world, again, very similar to the Indigo. In fact, the person who invented Indigo, believe it or not, his name is Benny Landa, a genius, literally a genius. He invented indigo printing. He got it established, and then he sold it to HP. Sold all the rights, sold everything to HP. HP's just continued to perfect it. So he wasn't done. So I guess he was bored after he invented indigo. So he turned around and he invented with something called nanographic printing. And that's where the parentheses Landa comes from, because that's the last name of the person, Benny Landa. He's literally, I've met the man, he's literally a genius when it comes to imaging. But basically, it's very similar to a indigo press, but instead of using a mineral oil or an oil-based ink, this is using a water-based ink. Very similar concept, where you have a drum that's charged by a laser to accept the ink. The ink adheres to the drum, and then it's actually transferred to the substrate through a blanket, like the indigo press. And this technology is, I would say, is come out probably about 4 or 5 years ago. Was introduced to the industry. I would say it's kind of still in its infancy, but right now there's currently about 57 printers in the US who have installed a Landa press, and they're using it for commercial printing, packaging, and publishing applications. Nowhere near the install base of Indigo. We don't have the numbers, but there's literally thousands and thousands of Indigo presses that are installed into the US. And so while this technology is relatively new, they're still working out some of the bugs. It's been proven, and its popularity is starting to grow. It'll take a while, I think, for it to eventually get to the thousands and thousands of installs, but still, it is out there, and you may run across that. Now, the other major, in my opinion, from all the digital technologies that were being tried, inkjet is by far, I would say, the most common in terms of the number of presses or devices that are installed, because the versatility of inkjet. Just a quick lesson on inkjet, but basically inkjet printing, the printers spray tiny droplets of ink directly onto the substrate. So here it's a little bit different because we don't have a charged drum. The technologies I was talking about, the indigos, electrophotographic, those are all using a charged drum. In this particular case, for an inkjet printing, there's two types of print inkjet print nozzles, thermo and piezoelectric. Each has advantages, each has disadvantages, but basically those nozzles are used to create individual drops of ink that are then transferred or jetted onto the substrate. The applications are just phenomenal in terms of where inkjet and what inkjet's being used for. Obviously, you may be familiar, a lot of people have either in their home office, if you have a home printer, it's either going to be an inkjet printer or it's going to be a dry toner type printer. But typically, most people are using inkjet printers for their home. Again, it's a personal choice. And that's really where inkjet printing got its start, was home office. And what happened is, as additional research and technology got put into into inkjet printing, it became better and better and better, became higher quality, and became larger. Extremely, you'll see some of these images. It became much larger than basically your home inkjet printer. So when you think of commercial applications for inkjet, one of the things I always like to tell folks is think of your home inkjet printer on steroids. And so the applications, I said, are commercial printing, wide format printing, textile printing, and packaging. And so inkjet is probably the most versatile out of all of the digital technologies because of the materials that it can print on, the substrates that it can print on. And then it comes in different formats. So you have water-based inks, solvent-based inks, and then your UV cured inks. And again, the choice of ink is going to be dependent upon the product being produced, typically the substrate, what has to occur or what longevity must happen with that substrate, things like that. So that'll drive your ink type. And then there's different types of devices, and we're going to talk about those. We have the term flatbed, and as the name implies, if you look on the image immediately to the right, that's a flatbed technology. And think of like a rigid sign, or think of a point of purchase display. That's going to be a flatbed type of product. You have wide format. Wide format is on the far right and the lower side, and that's going to be primarily wide format. Think of signs as well, like flexible signs. Signs that you might be driving down the road and it says, "Hey, we're open." That's going to be could be a wide format. We have a term called roll to roll, where basically you have a roll of substrate that gets printed on, it unwinds, it gets printed on, it gets rewound up. And then we have what are called production sheet fed and production web fed. So if you look at the image on the far upper right hand corner, that's an HP inkjet web press. Absolutely fascinating. There are a million, get this, there are a million inkjet heads in each one of those printing units. At any one time, 500,000 of those inkjet heads are firing. So think about that a second. 500,000 inkjet heads are firing. And the reason why there's a million is that there's a backup inkjet head. So if for whatever reason one of those inkjet heads doesn't fire, the one sitting right behind it will fire in such an infinitesimal amount of time that you won't lose your image quality. And so that press sitting up on the far right-hand side is a web press. And so literally it's going to be used, those presses typically are going to be for labels or for commercial printing, where they're actually going from a roll to roll, where you're unwinding a roll, printing it, and rewinding it back on a roll. The sheet fed press, which is the last one in the center on the right, that's basically a production sheet fed press. Again, similar to, say, a sheet fed lithographic press. Individual sheets of paper are fed through the press, and it goes underneath the inkjet heads where it gets printed, and out on the delivery end comes the finished product. I have a video here. I'm going to try to, I don't think you can hear the sound. It's just some background music. What I'm going to do is because we've been talking about these, sorry about that. I was trying to turn down the sound. So we've been talking about these from a static perspective. So I wanted to share with you just a short video of a roll-to-roll digital, basically a digital press. It's printing on fabric. And so again, just another substrate that the printing industry is printing on. And you'll see, for coming around the back side of the press, you'll see where the inkjet heads are traversing back across the width of the substrate. So this is roll to roll. And so you see the inkjet heads are firing as they're moving across the width of that substrate. And you can see the images that are being transferred to that. And this is typically, because it's fabric, it's generally going to be a water-based. It could be a water-based system. This could also be a solvent-based, or it could be UV. Now, and I think in this particular example, this is a water-based. And so now you have the image that's on the substrate or on the fabric is going to go through a dryer. Basically, the dryer is going to evaporate some of the solvents, the water, the co-solvents that are in it. Then it's going to get wound back up on the roll down here at the delivery end. And so it's basically an example of a roll-to-roll inkjet. But I just wanted to show you with some of these inkjets, the way that the inkjet heads go back and forth across the substrate. And I think Mark had asked me the question when we were going through this, what would that fabric be used for? And it could be used for a variety of things. It could be used for decoration. It could be used like a wallpaper. It could be used for pillows, for example. It could be used for fabric covering on, say, on furniture. And we have members, believe it or not, that print carpeting. That's another application of technologies that people actually print carpeting. You can't underestimate the vastness of the printing industry and how you interact with print. And I think hopefully by the time we're done with this presentation, you'll think of print a little bit differently than you did before you sat through this presentation. So let's talk about dye sublimation. Dye sublimation, again, another digital technology. what is fascinating about dye sublimation, which really, when I first learned about dye sublimation, I was absolutely fascinated by this process. So basically, a solid dye is heated until it turns to a gas, and then bonds to the polyester or polymer coated surface. So basically, what it does is it becomes a permanent part. Almost becomes a permanent part of the substrate. And so again, fabric printing, dye sublimation has really come a long way in terms of its application. But for promotional items, photo printing, signage, carpeting, a lot of carpeting can be done because you want that image to actually adhere to that substrate. You don't want your image to wear off in your carpeting. Say, for example, you had a nice pattern, or you had your company's logo, and say because people walk across the middle of that carpeting, that becomes worn and indistinguishable. Obviously, that's not going to be a good thing. So when you have dye sublimation, you literally are making the image almost part of the substrate, and that's the only process where it actually, I would say, it actually becomes part of the substrate more so than the other technology. Other technologies, think of them as surface treatments. In other words, they're going to be residing on the surface of the substrate. But dye sublimation is a different type of technology. And again, there's a lot of products that are printed by dye sublimation. The most exciting thing happening from a screen printing perspective is the direct-to-garment printing. Direct-to-garment printing, again, think about our digital technologies. We're going direct to something. So in this case, we're eliminating a screen. So, when you do you think of screen printing, and you think of apparel decoration, you immediately think, we're printing t-shirts or we're printing hoodies. And a direct-to-garment printing basically is using inkjet. That's why I said inkjet, in my opinion, is probably the most versatile digital technology that we have out there. And it's printing water-based inks directly onto fabric. Typically, though, you're limited with direct-to-garment printing because it's typically cotton. So cotton is the primary material where direct-to-garment printing is done for. But when you think about it, there's a lot of cotton garments that are printed, and it isn't just garments. It could also be tote bags, for example. It could be other materials that think of textiles and fabrics that are printed. And so direct-to-garment printing allows you to basically take that image right from the computer, send it out to the output device, and it literally prints that garment. Now, there's some pre-treatment that must happen, and then the garment is then heat pressed to cure or set the ink. But basically, we're transferring the image directly via inkjet technology. And then also there's something called direct-to-film printing. So the direct-to-film printing basically is kind of an intermediate. So basically, if you go into we were at the beach this summer, and you go into some of those shops and you see a lot of t-shirts, right? And so you want to get a t-shirt for the beach that you're at, and you like a particular design. They have transfers that have already been printed. And basically what this does is we're printing a transfer onto a PET film using specialized inks, and applies adhesive to the wet ink. And then that film is cured, right? Then when I want to transfer that image onto the garment, it's basically heat pressed. And so instead of having to keep all these different preformed transfers, I can actually produce my transfer on demand. If you say you want to put an image of yourself, that you took a photo of yourself at the beach and you want a t-shirt made of that, you can literally walk in, hand them or email them, or hand them the camera card, or give them a thumb drive and say, I want to print that image on a t-shirt because I want that to be my t-shirt to reflect our vacation that we had at the beach. They'll be able to do that. They'll be able to output it onto the film and then transfer that directly to the garment. And basically, this is a bit more versatile because it can print on cotton, polyester blends, nylon, and other materials. And so it's not as limited as the direct-to-garment printing, but the direct-to-film printing, you have a lot more substrates that you can print on. And again, things like hats, tote bags, other fabric-based items where you would want an image that would be put on that particular garment, you can do it through the direct-to-film printing. So again, digital is allowing us to have flexibility. It's allowing us as an industry to have different materials that are printed with different types of technologies. And so let's move into probably the last part of my presentation, and I can open it up for questions. Let's talk about environmental issues, because obviously what happens with digital is that the terminology I like to use is that digital is different. In other words, it isn't. Yes, it's a huge improvement from the environmental perspective. You don't have the analog type of technologies. Like for analog, we basically a great example is that, in an analog world, printers were buying cleaning solvents, in 55-gallon drums or 30-gallon drum sizes. When you move into a digital world and digital applications, basically they're starting to buy gallons and quarts of cleaning solvent. There's not a lot of cleaning solvent because you don't have to clean the ink up. The inkjet, if it's inkjet, those heads clean themselves. There's very little, you may have to flush them, but there's very little solvent used, and the ink is used more judiciously, so you don't have ink waste you have to deal with. And so there's clearly a lot of advantages, but still you have to worry about some of the environmental issues associated with digital technology. So, for example, toner inkjet cartridges may be considered hazardous waste. More so inkjet cartridges if they have ink in them. Again, not all those cartridges can get emptied completely, but you might have those as a concern. So that's an issue that you have to be cognizant of. Solvent and water-based inks do emit VOCs and possibly sometimes HAPs. Again, not a lot of hazardous air pollutants associated with the digital technology, but there are probably more VOCs. And as you think about it, some of those larger presses, obviously, if it's a small inkjet unit, the VOC emissions are going to be minimal. The larger presses, you can get upwards of say, a ton, maybe a ton and a half of VOC emissions. Again, from an analog perspective, some of the presses, they're 4 or 5 tons of emissions, and now we're dealing with maybe 1 ton or up to a ton or even less than a ton. So again, a very, very huge improvement from a VOC emission perspective, but nevertheless they still emit VOCs, and depending upon where you're located and what air permit requirements might be there, you may or may not have to have an air permit. Most digital technologies are usually fall under exemption levels and don't really need permits, but nevertheless it's something to be aware of. Indigo and Landa presses do emit VOC. Again, Landa's a water-based technology. Indigo is mineral oil-based. What's interesting about the indigo presses is that they generate waste imaging oil because the solvent, I put that in air quotes, the solvent used for indigo presses is basically, it's a mineral oil. It's a very high boiler, low vapor pressure, and the indigos have an onboard recovery system. So for the ink that is not transferred, that gets scraped off the blanket, actually it separates the imaging oil out of that and recycles and reuses the imaging oil. And so over time, that HP has really, really done a fantastic job. And the amount of imaging oil that those indigo presses generate are relatively minimal. The first indigo presses would generate, somewhere between 4 to 5 drums a month of imaging oil. Now you're lucky if it generates, a drum, every 6 months or so. So the amount of imaging oil that's being generated from a waste perspective is down significantly. And a lot of printers have moved to the newer versions of the indigos, and the onboard recovery system has become much more efficient. So if we're in our pre-press, we still have our direct-to-plate chemistries. Again, those could have environmental concerns. The biggest issue is that in the direct-to-plate chemistry for litho, that's going to have a high pH. The direct-to-plate chemistry for flexographic printing tends to be solvent-based, although some of the newer technologies coming out are water-based, which is a move in the right direction. But if you have direct-to-flexo, which again is another technology out there, and of course we have solid waste issues. We have printer cartridges in containers, computer monitors, used equipment, that type of stuff, and depending upon the type of equipment you're generating, some of that material can be recycled. There may or may not be a take-back program by the manufacturer, but then you obviously have the solid waste issues associated with the equipment. Now, there's still issues, involved in printing and waste generation and printing, but I'm focusing here on primarily on just the digital type technology. So that brings us to the end of the presentation. I know it was a quick trip through all of the digital technologies, what's happening in terms of the evolution or revolution. The one thing I can say about what I've noticed, my observations with the digital technologies is that in some instances, digital has completely overtaken certain segments of our market, which were printed primarily via analog. So, in a lot of screen printing applications now, you see complete digital. There's not even a screen press in a facility anymore, and we see that, for example, with apparel printing, you see the digital, the direct to film and direct to garment is starting to make a lot of inroads where people don't have to make screens anymore. You don't have to image the screens. You don't have to develop the screens. You don't have to clean the screens. It's a much more economical workflow. You produce very high quality images. You have much less waste. It's really a huge improvement over the analog system, and like a lot of commercial printers now, you'll see printers that are doing lithographic printing. Rarely will you not see some type of digital equipment. There's a lot of wide format being done. If it's somebody's focused on packaging, commercial printing, you'll see indigos in those facilities. There is rarely do you ever find a printer now that isn't just solely analog, that they both have a combination of analog and digital. And over time, we've actually had members who completely got rid of their analog commercial lithographic presses because they went to the sheet fed digital presses. And so you see in certain instances, analog presses aren't even present in printing facilities, and they've gone all digital. And so as time goes on, as R&D continues to be focused on, investments are made into the digital technologies, I just see more and more of those types of circumstances occurring. And really, it's about run length. And so as the digital technology gets better, the run lengths get longer, and the cost per substrate or cost per image comes down. You'll see more digital technologies being moved in to supplement the analog technology. So it's really been fascinating to watch how this has evolved and unfolded in the industry. So with that, Mark, I'll see if there's any questions.
So Gary, there have not been any questions.
So this is Mark. Gary, you had mentioned when you had helped me, I don't know if it was 2 or 3 years ago, that packaging was hot. And I know at one time you could have a packaging company. They did the printing, they made the package. They also even added the product into the package. Do you still find that to be going on?
Yes. The growth in packaging, it continues to grow because we have a lot of commercial printers moving into packaging. And I think the primary reason for that, Mark, I think we talked about was really COVID, because COVID changed behavior, and people changed a lot of shopping behavior. And so you now have more and more products being bought remotely on the internet. And as a result of that, they have to be packaged themselves in the packaging, right? But they have to be shipped to you. So that's why you've seen this tremendous growth and increase in packaging. And you also have the customization, as I mentioned about like you have the microbrews, for example, where they want to sell their product to the public, but they're not they're not distributing their product nationwide. It's just local. And so you have a lot of that customization going on with packaging as well. And so that drives the demand for customizable and specially packaging. So yes, packaging is still red hot in the industry.
So while we wait on anyone else asking questions, and hopefully people don't think it's up to me to ask questions for them. So again, as Julie had indicated in the chat, you can raise your hand or unmute. And I don't know if anyone. Oh yeah, Tony, unmute and ask your question.
Well, hey Gary, first off, thanks for all you've done for us for over so many years, being with us for forever and helping out and having our back. We appreciate it. So I have become aware of a newer technology, and I'm wondering if you think this is going to be a really tough one for you. Because, I mean, I see you guys a lot like the dry cleaners. Your emissions have just plummeted. the demand has changed, like dry cleaners, because people don't dress up as much and they weren't going in the office and stuff like that. But you guys, the printed material is turning into a lot of digital stuff. So I saw new technology where you can have an art frame on your wall that has, I think it was called liquid ink or something like that, and you can choose any image you want and it'll look like it's a printed picture. Do you know
Yeah.
about that? And do you think that's gonna make it rougher?
No, I don't think so. I think that's limited in terms of its market. I mean, the big thing you guys remember when Amazon came out with Kindle, right? And this is kind of an analogy, but everybody was like, "Oh man, that's it. That's the demise of printed books, right?" Because everybody's going to go to Kindle. What's interesting is that the exact opposite has happened. The growth in printed books went up, and a
Really?
lot of people prefer to have the old analog book in their hands versus a digital read. A lot of people, try to read your Kindle at the beach. It's hard to read. So I think that's more of a novelty. I don't see it changing like the art world. I don't see it changing like picture books, for example. Picture books are very popular. People come back from a vacation or where I have 3 daughters, and 2 of them are getting married this year. So, doing the photo books of the wedding, and photo books of the reception. My daughters have gotten several of those. You know what I mean? We've sent away for them. So I don't see it as a direct threat to that type of print. But print has learned to live with a lot of other technologies. You remember, radio that came. I don't remember radio, but when radio came out, before radio, it was the only one of the best ways of mass communication was print. And radio came, and then television came, and then the internet came. So print's still hanging in there because there's advantages to having things in a printed form that none of the other communication methods will compete with.
So Gary, we have something in the chat. What about the complexity of printing on food? I don't know if you've seen those ice cream cakes, and I don't know if they're, an application where you print on an applique, but it's got to be, I assume, edible. So that would seem to pose some challenges.
Yeah, well, that's going to be more a digital application, obviously, because you're going to have a digital. That's going to be inkjet output. But in order to, those are probably going to be food dyes and food approved dyes and not inks. But when you print, if you have FDA regulates the food contact. And so when you have food contact items like that, whether it's an ink or a dye, it has to be approved by the FDA for direct contact with food. And a lot of people think, oh, I get this question a lot. I need an FDA approved ink because I'm going to be printing food packaging. Well, FDA doesn't approve inks. FDA doesn't approve dyes, so to speak. Well, maybe a dye. FDA approves chemicals, individual chemicals for direct food contact. And so you have to make your product out of the approved chemicals. So you can't go and buy an FDA approved ink, but you have to buy an ink that's made with FDA approved components, if that makes sense. So in that particular instance, like printing directly on food, it could either be dye based or it could be pigment based as well, because pigment based is an option. But every one of those components that's in that material that's being applied to that particular food has to be approved by FDA.
Yeah, thank you. We have another question in the chat from Belinda from Idaho. What do you see as the biggest air pollutant and water pollutant in the current printing technology?
Well, from an analog or a digital perspective, probably the biggest, it depends on, that requires a value judgment, but I would say probably VOC emissions are probably the biggest impact that printing has, followed by, from an analog perspective, from a water perspective, it's probably going to be like your direct to chemistries, your direct to plate chemistries, your direct to screen chemistry. From a wastewater perspective, I would say those are your two leading areas. Now, some would argue, solid waste, which wouldn't disagree. Solid waste is up there too, because as we know, solid waste is a big challenge. It may not always be hazardous waste, but it could be hazardous and it could be solid. So, if I were to pick number 3, I'd probably go hazardous waste, because you're going to typically find a lot of hazardous waste coming from analog printing versus digital printing, because there's very little waste chemistry that's generated from digital. I mean, indigo generates imaging oil. That's going to be a waste oil, a used oil. Some states regulate it as a hazardous waste. Most states do not, but usually that can be recycled.
So with the use of digital, I assume your VOC emissions go down as well as your
yes.
generation of hazardous waste.
Yeah. Well,
So-
quite dramatically from digital. Like now, don't get me wrong, if you have a solvent-based digital operation, those can generate a couple tons of emissions, right? But a lot of digital is going to be water-based. So water-based, it's going to be less than a ton. There's VOC in it, but it's not anywhere near what you would see from a conventional analog, where you can have 4, 5, 6 tons of emissions coming from an analog press. I used to, my rule of thumb was, if you had a 4-color sheet-fed offset press with a coater, that's probably about 4 tons of emissions, was a rule of thumb. Now, some of these digital devices, we do calculations. They're way below, they're less than a ton, and they run pretty continuously.
What about emissions associated with dryers? Has the need for drying capacity gone down or stayed the same?
That's going to depend on the ink, but from a analog perspective, yes, dryers are still present. You have heat set web, litho presses, or solvent-based flexo presses, solvent-based gravure. They're going to have dryers and a lot of emissions associated with them. And usually there's control devices. So those are going to be controlled through add-on control devices, typically oxidizers. But, if you have UV systems, generally the emissions are minimal. The water-based, as I said, the emissions are minimal, because you just have to drive the water and a little bit of the co-solvent off the substrate to get the ink to dry.
So yeah, I thank the people who put questions in the chat. So Gary, what about pigments that contain metals? How prominent are they? Say like aluminum. And I don't know if it's for aesthetic purposes or for the purpose of scanning.
Well, okay, so almost all pigments contain some type of metal. So the question, maybe you're asking like heavy metals. If that's the question, like heavy metal based pigments, we don't use heavy metal based pigments typically in printing. Like lead, chrome, yellow was phased out, almost 50 years ago. So we're going to use organic based pigments, and some of those organic pigments can have a metal in it. Like a blue or a green will be a copper-based pigment, but it's going to be primarily organic, but it'll have copper associated with it in the pigment. So aluminum, for example, if you see something that's silver, printed silver, or like a scratch off, that's usually going to have aluminum as part of the pigment, as part of the material. Gold is typically brass. So if you see things that are printed brass, that's going to be a gold, that'll be a brass type pigment. But I would say by far the vast majority of the pigments are going to be organic based. Some of them may have a metal in them, but there's not going to be. We're not using heavy metals, if that makes sense.
Yeah, yes, it does. So Troy with Minnesota asked the question: are VOC retention factors applicable to any of the new digital printing technologies?
That's a good question. I would say probably not, because they haven't been studied. The retention factors that have been studied apply to the analog, and for digital, we don't apply any retention factors because they haven't been studied. And I would say, just from my opinion, that the retention factor would be relatively minimal if at all. But that's a great question. Oh, Mark, you're muted. Oh, there you are.
Yes, thank you. We have Lena from Kansas State University. Is there any process where analog printing is preferred over digital?
Absolutely. It's going to be dependent upon your image quality and run length. So digital is not capable of producing every single image. So for example, I used earlier Chiquita banana stickers, which is kind of an interesting example, but there's no way it's economically feasible to print those with digital applications. You're going to have to use a process that's really long run. Printing, typically the cut point is going to be length of run. So if you have a magazine, for example, I don't know, or a catalog like LL Bean, for example, LL Bean, they're not going to produce that on digital. It's way too expensive. You're going to have the analog types of printing that are done for that. Fine artwork will be done typically not with digital technologies, although digital technology is getting better. But things like that in terms of where if you have, for example, wedding invitations, because that's common in my house this year, you can a lot of times, and I didn't really mention letterpress, but a lot of times letterpress like engraved invitations, that's going to be letterpress, where you're going to have a raised image area. Then you wouldn't be able to do that with digital. So there's still a lot of applications for analog, but as I said, digital is clearly making tremendous inroads into that analog world.
And with regards to sustainability, and Gary, you have helped me a lot. What about the use of bio-based or bio-derived inks? How common is that? And is that something that's going to expand in the future?
Well, Mark, when you think about a lot of the ink systems that we have a lot of biorenewable content in them anyways. But yes, I think as the ink manufacturers have really put a major focus on sustainability, and they are improving, expanding their selection of those types of inks, and increasing the biorenewable content of the inks. The way we like to look at it is biorenewable content. That's probably the best way to look at it. But even your traditional analog inks have a lot of biorenewable content in them anyways. But the ink manufacturers are constantly exploring and adding new components to those ink systems. So yes. Yeah, I mean, to me, sustainability is really this phrase I always like to describe it is that while it was a nice thing to do, it's now a must thing to do, and that sustainability is being demanded in a lot of markets that our members serve. Printers, if you think about printers and where they fit, they're in somebody's supply chain somewhere. They could be a primary supplier, they could be a secondary, they could be a tertiary supplier. But because of all the focus on supply chain and trying to make products more recyclable, closing the loop, looking at reductions in carbon emissions and carbon footprint, printers are part of that, and our printers put those demands on their suppliers so they can meet their customers' demand. So the ink companies, I have to hats off to the ink companies. They're doing a lot of work in this area.
Now, you mentioned a lot of direct to substrate printing. This was a company in Indiana, and I think they have several locations in the US, but they have what they call direct to container screen printing. I don't know if that's just limited to certain types of industries, or that's broad based for any type of, say, like glass or metal container.
Yeah, it may. I'd have to get more details, Mark, but I'm hazard to guess that the container is probably a curved or rounded surface, is what I'm thinking, and that's why they're using that type of process. But a direct to screen print would tell me that they're making the screens, they're imaging the screens directly, but not transferring the image. They may be still going through a screen to transfer the image. It may still be pushing the ink through a screen. because otherwise they would be doing digital.
Okay. So yeah, it is a curved surface.
Yeah.
And it was Eckhart America. I don't know how common they are. But yeah, thank you for that. I could probably spend the next half an hour asking you fascinating questions and getting fascinating answers. But I do thank you for your time. We probably ought to limit the recording limit so that, you know,
Yep.
my next challenge is going to be how do I convey this to our YouTube channel? And I'm not certain how to do that. What I would like to do, I've got a, and you know, as you know, EPA is going through a lot of